Alright, so in Chapter 2, Section 5, um, we're finding solutions of polynomials. So we're not looking at squareds anymore. We're looking, well, there could be squareds, but it could be any polynomial, and we're looking for real and complex solutions. So real and imaginary solutions. When we're looking at this section, just like on any of these, when it says find the rational zeros of the function, or the real zeros of the function, like we just want the ones that we can see. And so visually, let's look at this first one. If I had to figure out these, or this one here, and I don't know how to factor something to the fourth power, I would graph it first and get an idea of what it looks like and where it crosses. So I would go to Desmos, and again, this is something that you're allowed on your test, but I'd want to see where's a good place to start. What's a possible zero that I could try to divide out using synthetic division or long division. So if I graph this thing, plus x cubed plus x squared plus 3x minus 60 or minus 6. That could be it. So if I look at that, I see it crosses at 1, and I see it crosses at -2. So these are things that I'm going to try to divide out, and I would do that through synthetic or long division, what we did a couple sections ago. And there's some examples on the supplement for that section. When I get to something like number 3, list all the possible rational zeros f, that doesn't mean that these are solutions, they're just possible. And in the text, they talk about these on page 155. So these are your possible rational zeros. So that's just taking your very last term of your last coefficient and your first coefficient and looking at all the different factors. So when looking at this problem, our factors are the same on mine as 9 and 9. So all the different factors are 1, 3, and 9, and then 1, 3, and 9 on bottom. So that's how I'm getting, it could be 9 over 9, it could be 3 over 3, or 1 over 1. It could be 9 over 3. It could be 9 over 1. It could be 1 over 3 or 1 over 9. And again, it could be positive or negative. So these are just places like if you didn't have technology and you wanted to start guessing what's a possible zero, well, you could list them all out. Kind of an archaic process. When looking at number 4, find a polynomial function. So they just gave 2 solutions. So that means we have to find the third. But in our text, on 158, when you have an imaginary part, it comes in pairs. If you have something in this form, you also have this one. The idea is when you're doing the quadratic formula, you get that plus or minus piece. So one's plus, one's minus. Has to work that way for our complex solutions, our imaginary solutions. And so they're called conjugate pairs. So when we're doing these, 3 is a solution, 8 minus 7i is a solution, and then also 8 plus 7i is a solution. And I'll work this one out in the supplement to show you how to factor it or FOIL it all out, multiply everything all out, so you get something that looks like this. And then the other one, all these are pretty much similar. On number 15, so a product of linear factors. So again, you're just factoring this thing and then listing all the zeros. So I will show a video for number 15 as well.